Hello everyone. This video is part of a series where we are exploring TypeScript's features with the help of a React application. Our main goal here is to learn how to type our code better with TypeScript in order to improve confidence and velocity in development. In the previous video, we added some static analysis and some formatting checks before committing our code in the React application repository. And in this video, I want to discuss some basic types of TypeScript. Whenever we discuss some theory, which is going to be the case quite often, we will use the online TypeScript playground, right? You can access this by coming to typescriptlang.org and then clicking on try in your browser. This, I have just deleted the initial content that it comes with, so you should get the same screen quite easily. The first basic type I want to discuss with you is the boolean type. And the boolean type can only contain true or false as a value, right? So it cannot contain numbers and it cannot contain strings. A way of defining this is by simply passing a colon and the name of the type after the variable declaration. Here it should actually be better if I wrote let, for example, because I'm not initializing the variable. I will do this change on the other variables as well as we go through the video. So if I come here and I say let is in cart of type boolean, then I am able, oops, there is a small typo here, then I am able to say that is in cart is equal to false and is in cart is equal to true, right? Imagine this is a product and this is a property of the product, so we want to know whether it is in the cart or not. Now, if I try to do something like is in cart is equal to 5, for example, then TypeScript will start to complain about this because 5 is not of type boolean. 5 is of type number. Another way of letting TypeScript know of a type is by directly initializing the value of some variable, right? So you see that if I don't initialize it, then TypeScript allows pretty much anything. If I hover over is in cart, then this is of type any, and we definitely want to avoid the type any because it basically disables TypeScript checking for that specific variable. So whenever we can type it, we will type it, and we will make sure that, or we'll try as much as possible to type the variables. So if I don't pass the colon boolean here, like so, but I initialize this variable to a value of false, then TypeScript is going to use what is known as type inference to derive the type of this variable here. And type inference is going to look at the shape of the object we have on the right side of the initialization, and it's going to assign this shape to the variable here. Now, this is fine for basic types like boolean, numbers, and strings. But as soon as we start getting more complex types, then this is not very scalable from my perspective because it makes it hard to reuse types, right? So imagine we have a product. The product is a somewhat complex object, has maybe 5 or 6 attributes. And we want to use the definition of a product in multiple places. If I use type inference, I don't have a single type that holds the shape of the product object that I can then reuse and assign to a certain variable, right? So this we could say is of type product like so. Now I have an error here because I don't have the product defined, but later on we will define this product type and then we will see how we can use it. So this is the boolean, right? This is the boolean. I will use the colon boolean here just for the sake of getting used to this syntax. And we also have a type number, right? So in TypeScript, numbers are, so more generally in JavaScript, I think numbers are only big int or float, right? We don't have such a type as an integer or a decimal or some other specific number types. We have either big int or float in JavaScript. So if I have another variable that I type as a number, for example, and here I need to adjust it again, for let product price be a number, then I will be allowed only numbers in that variable. So let product price to be, let it be a number. So I can say the product price is equal to 10. That's okay. I can also pass a floating value, 10.50 for example. I can pass a negative value. That's also not a problem. Minus 10. Of course, this doesn't make sense from a semantic perspective, right? So the price can never be negative, but this we cannot enforce with TypeScript. We can only say that it's going to be a type. However, if I try to pass a string like so, 10 for example, then TypeScript will start to complain, right? This 10 here is different than the 10 above here. And the product price does not accept strings. Now, if you want to parse it, you could definitely do it like so, parse int, and then between parentheses, and then everything is fine. Maybe you are receiving this value from some external JSON source that sends only strings. It could be the case, but then you need to do the conversion by yourself. Okay, so this, only the string 10 here would be a problem for TypeScript. In addition to the number, another basic type that we have is the string. So the string accepts only strings, and it can be typed as product title colon string, like so. Let product title be of type string, and then we can write whatever strings we want. So I will remove this to prevent errors, and here I'll say let product title be of type string, right? So then I can say product title, oops, is equal to my product. That's okay. I can also say product title is equal to great opportunity, like so, but I cannot say that the product title is equal to 5, right? That's a problem. TypeScript starts to complain that my product title cannot be a number. And just a comment, as you can see here on the left hand side, all the types are removed. Once we really compile this into JavaScript, then all the types of the variables, they are removed. And this is quite interesting to see what is the output of TypeScript, right? That's why I also like this online playground where we can see the result in JavaScript. We also have a declaration file, and we can enter into more details of these declaration files later on. The final basic type that I want to explore with you is the array type. And the array type is basically an array with the defined types. So right now we know boolean, number, and string. We can define additional types later on, but for the moment, let's say that we want to create an array of strings, right? So for TypeScript, the syntax for this, we have two possibilities. We can either use a square bracket. So let me adjust this let here and here, oops, like so. So we can either use the square brackets after the type of the variable, or we can use the array type constructor. Now the array type constructor, you may be seeing this less than and greater than signs here, and you may be a little bit confused what it means, and it's okay because this is a generic construct. But what it means is that I am passing the specific type that this array is allowed to contain, right? So this array is only allowed to contain strings. Let's say this in practice. If I come here, I will remove my wrong code, and I will say let product tags, which is going to be of type string array, like so. Then I can say product tags is equal to, how could it be, cheap, let's say. That's a cheap product, right? So this is okay, I can do that. But if I wanted to, instead of cheap, write 5, then it's a problem. And TypeScript will say you cannot have a number. We are expecting only strings within this array. Now, what is more interesting here, that by typing a variable as an array, TypeScript is able to tell us, or is able to make it available to us, all the properties of an array, right? So an array is not only, we can only, wait, let me rephrase this. we can not only initialize the array, but we can also perform some operations on the array. So let's see here, product tags dot, and then as you can see, we have all the different methods that we can use in an array. So if I wanted to add a new value, I would call the method push, and then here I can add a new item, right? So that would be chip, kitchen, like so, and that's okay. Later on, if I do a console.log in the product tags and I run this code here, then I will get chip and kitchen, right? So what is very, very beneficial from TypeScript is that, and maybe you start to realize the major benefits of using TypeScript, is that by using types, we are also able to ensure or to enforce that all the methods can be easily made available by TypeScript. So now I don't need to remember that the array has a push method, or does it have a pop method? It has a pop method. Does it have a length method? It has a length method. But of course, all these methods, as you can see here, if I say pop, this already complaining, and this is another benefit because, well, the pop method really does not expect any argument. It just removes an item from the array. The length method also doesn't expect any argument, but I cannot call this. So the length is not a function, right? The length is simply a property of my array. So as you can see, TypeScript starts adding all these little checks that we could really run into problems here if we were to compile this. If I try to run this, well, this doesn't really compile, so it cannot run. But the idea is that if I were to run this in a JavaScript or in a, exactly, if I were to run this file, for example, on the browser or in a local JavaScript compiler or something, this would throw an error, right? So the length is not a callable object. The length is just a property of product.tags. And TypeScript is already highlighting this to us at development time. So in compile time, it does not allow us to compile the code if there are any errors like so. So we can also get rid of the square brackets, and if we want, we can use the array constructor like so, array string, and all the properties will still be the same. Now here, a small addition, we will enter into the union types a bit later in the future. Yeah, a bit later is always in the future. But if I also want to allow for a number, for example, then I can use this constructor, this vertical bar here, that in TypeScript means or, right? So think about it as you would use or in JavaScript. And now I am able to pass both strings and numbers to my product tags array. Of course, it's a little bit more advanced. We will go back to this and see more specific examples. For the moment, I think we have done good progress. So if you want to get updates about new videos every time I upload them, make sure to subscribe to the channel. I try to add videos every day, and you will get a notification as soon as they are made available online. Also, if you are interested in any development topic and you think it could be useful if I made a series out of it, or even a standalone video or some more extensive course, then write down in the comments. I always check the comments and I take your comments into consideration when planning the future series in this channel. For the beginning here, whenever we discuss this theory using the TypeScript playground, there will be no specific commits for the codes, right? So we will not work in our React application at the moment, but soon we will come back here, and once we are back to this React application, I will always make available, or I will always make the git commit of a specific video available in the description. So this is important because then you can compare your code with my final code and see if there are any problems there. Great. Thank you for your time, and I'll see you in the next video when we discuss enums. Thank you. Bye-bye.